So we've met differentiation, we've met one half of calculus. The other half is known as integration, okay? So what we've done is we've seen how we can get from a curve to dy by dx, how we can differentiate. So if 4x cubed, we want to differentiate, the power comes down to the front, we take 1 off the power, so we'd have 12x squared. The 3x differentiates to 3, and the minus 7 just disappears, okay? So this process we know is called differentiation, okay? So that's differentiation. Now, let's say we have been given dy by dx. So let's say dy by dx is 4x plus 5, for example. And what I want to do is I want to work out what the y would have been. Okay? So I'm starting now with the dy by dx, and I want to work out what y is. Well, so something must have differentiated to get that 4x. Okay? So what would differentiate to make 4x? Well, we can see that as we differentiate, we take 1 off the power. So our original x up here must have been an x squared. Okay? And so when the power came down to the front and multiplied with whatever number was there, I must have got 4 before I then took 1 off the power. So it must have been 2, so that 2 times 2 makes that 4. So y would have to be 2x squared. Now, if I've got a singular number there, I know that when I differentiated 3x, I got 3. So I must have had 5x in order for that to differentiate to get 5. Okay? Now, how about this minus 7 that I had there? Because when I differentiated, the minus 7 just disappeared. I lost a bit of information. Here, I don't have that information. I don't know if the original curve had plus 100 or minus 600 or plus pi or whatever. I don't know what that number is, and so I must put in a number replacing it. Okay, so a number that we're going to refer to as the constant of integration. So this process that gets me from dy by dx to y is known as integration. So differentiation, going from y equals to dy by dx equals, and integration goes from dy by dx equals to y equals. And effectively what you can see is that the power, the index, decreases, differentiation, d, and here the power, the index, increases, increase, integration, I. Okay, so integration for increase, differentiation, decrease. So is there a neat way of getting from here to here without having to kind of unravel things? Well, thankfully there is. Because if we're starting with dy by dx is equal to x to the n, okay, then y is equal to add 1 to the power and divide by the new power, plus this constant of integration c. So to get from there to there, you add 1 to the power, divide by the new power, plus c. Okay, so for example, if you have dy by dx is equal to x to the 4, then y, add 1 to the power, divide by the new power, and then add a constant of integration. Now, before we go any further, is there a situation where this is going to fail? And yes, there is. There is a value of n for which this is going to be a problem. And that is when n is -1. Because when n is -1, I'm going to get -1 plus 1, so I'm going to get 0 in the denominator here. So you cannot, at the moment, integrate 1 over x, or x to the -1. You just can't do it, okay? We will learn a technique of how to do it when we get to core 3, okay? So that will be answered then. But for the moment, you cannot integrate x to the n when n is -1, but you can for any other value of n, okay? And this is the process.